Here's some data from the original Working in Biosciences module that was there before the biochemistry module. So it's exactly the same practical that you did when you were at level 4. You had to measure the weight of 150 microliters of water and the weight of 1 milliliter of water, and then you had to calculate the absorbance of one solution, which was 100x dilutions, and the other one which was 1000x dilutions. So in this case, what you were looking at was precision and accuracy. You're trying to figure out how much variation there is and how accurate the results are. Here we've got measurements for 41 pairs of students who've done those particular measurements. So we need to take a look at the data and see what's going on. Now remember, the key thing about this is just to think about precision and accuracy. So the only thing this data set is really going to be used for is descriptive statistics. You're not doing any comparisons, there's no hypothesis involved in this at all. It's just descriptive statistics. So the first thing is to get the data into IBM SPSS, and in this case I can go and set up the data set. So we'll just put initials. It's going to be the first column. It's not going to be numeric, it's going to be string, so it's therefore nominal. The next is the mean. So this is 150 microliters. Weight of 150 microliters. Microliters water, and the next one is the weight of 1 milliliter. These are by scales. This is the absorbance of 100 x, and the next one is the absorbance of 1000 x. So all of these are going to be numerics. Right, let's set up the data set. Now this time I'm just going to copy it over rather than import it because of that extra line at the top, which is going to make things a bit confusing. So Control C it, and then in data view Control V it, and I've got all my data put in. I need to add a couple more decimal places because it's to 4 in all of these. Whoops. So now the data sets look the same. So first thing I want to do whenever I get any set of data is have a little look at it and see if there are any serious problems. So you always want to go to Analyze, Descriptive Statistics, Explore. I want to put all of my dependent variables across. I want to, well, statistics is fine, 95% confidence interval is fine. Plots, I want to do my histograms. I can also look at some normality tests to see if the data is normally distributed, and then go OK. This is going to give me a lot of output, which we need to then go through fairly slowly. So let's start at the top. Weight of 150 microliters of water. The mean is 0.158. The confidence interval goes from 0.143 to 1.172. That's all nice. Weight of 1 milliliter of water, 0.98, goes from 0.967 to 0.993. That should be raising some questions, because 1 milliliter of water should be weighing 1 gram. So this confidence interval here from 0.967 to 0.993 does not contain 1 gram. This suggests that there is a problem with your data. Go to the absorbances, 0.449, go to absorbance 1000, the mean of this one is 0.70 whatever. Now that mean is a long way different to the confidence bounds, which go from 0.46 to 0.046 to 0.092, and here they go from 0.41 to 0.48. So these ones are approximately 10 times these ones, but there's a massive problem here shifting the mean. So again, there's some suggestion that there's some problems in the data. I look at Kolmogorov-Smirnov, I've got significant absence from normality, and the same in Shapiro-Wilk. I look at the histogram of the weight of 150 microliters, and there's one over here which is above 0.4, which is a massive difference. 3 times the value that it should have. QQ plot's a mess, the detrended QQ plot's a mess, the box plot's a mess. For 1 milliliter of water, I've got a couple of very low values as well. So what's happening in this data is I've got outliers. If I go and look at the box plot, I can identify the outliers of 30, 31, and particularly 38. If I look at the absorbances, again, it's not very symmetrical, and you've got some more potential outliers at the large level. And if you go to the absorbance of the 1000-fold, I've definitely got some outliers. These are most likely due to the people who are doing the experiment putting the UV cuvette the wrong way round. So putting the opaque side and therefore getting more absorbance than you should have. Hence these 2 values. So when you get data like this, the first thing you've got to do is think about how are you going to clean it up to make it usable. So in this case, what you're going to have to do is deal with outliers and specify what the outliers are going to be. So in the case of the 150 microliters of water, you want to specify any weight that is above 0.25 as an outlier. So you can do that by modifying the data set. So we go to the variables, we look at the weight 150, so we go to missing data. Now you can either identify single values or a range. So we want it to get rid of everything that is above 0.25 going up to infinity. So it doesn't matter what number we want to put here, so we can put 1. That's okay. So now I can go back to analyze, and I can go to descriptive statistics and explore. And let's just focus on that single value of weight for 150 microliters. Kept all the statistical plots on and press OK. So now, how does my histogram look? Considerably better. I'm still not getting normality according to the 2 statistical tests, but that's partially because there's a relatively small data set and it's got a reasonable amount of scatter. The box plot still struggling a bit, so now it's suggesting I've got one that's too small. So 22, 11 and 16 are poor data points. So that means 16, well, I'll have to look at what 16 is, and 22 means any value above 0.17 really. So let's go and alter it again. Go back into the data, change that now to 0.17, and I didn't have a look at what the 16th data point, so the 16th one is 0.1293, so I need to also add that as an extra data point that I need to remove. So range plus a discrete value, 0.1293, wasn't it? Let's remember 16, 1293. Okay, so now I can go back and do analyze, Descriptive statistics, explore, repeat it. Now see what my data looks like. It's starting to turn out to be much more normal. Now neither of the hypothesis tests for normality are showing that it's got any deviations from normal. The mean is very close to the median. The confidence intervals are much narrower. I've got much less variation in my QQ plot, and the D-trend is showing much less as well. And now my box plot is looking good with no labelled outliers. But I've had to mark those particular ones as outliers and problem values. So if I've got problem values like that, I then need to go back and think, why did they happen? Now this experiment is about learning how to use micro pipettes. So what probably happened is a person misused the pipette. So overpressed it, or pressed it down to the second stop when they only wanted to do the first, or did not expel the material correctly.